Hello, everyone. Welcome to our webinar, What's New in HiveMQ inside the HiveMQ 4.7 release. It's a pleasure to have you all in our special edition webinar today on our latest feature release. Before we begin the session, I would like to introduce you all to our speakers for today, Dominik Obermaier, who is the CTO and co-founder of HiveMQ, and Georg Held, who is the engineering manager at HiveMQ. And before we kick off the webinar, I would like to let you all know that we are recording this session and we will share the recording and the presentation in a follow-up email. If you have any questions during the session, please type them in the Q&A box. We will answer them during the Q&A at the end of the session, and all unanswered questions will be answered on the HiveMQ community forum. We will be running a poll at the end of the webinar. Kindly participate and provide feedback. It would be really great to know your feedback. Now, without further ado, I will turn the time over to Dominik. Welcome, everyone.
So yeah, thanks everybody for attending today. So it's really great to have you. So with me today is Georg Held, who is engineering manager at HiveMQ. My name is Dominik Obermaier. I am a CTO and co-founder at HiveMQ. So if you would like to connect after the webinar, talk about MQTT, IoT, here's the contact data. You can reach us either on LinkedIn, on Twitter, or via email. So we are very happy to answer any questions afterwards. But also, as Jayashri already said, we will have enough time to also cover your questions here today, or also answer things on the community forum in case this would be too elaborate or we run out of time. So in any way, your question will get answered. Okay, so we are going to talk about the HiveMQ 4.7 release. And I would like to start with giving you an overview where we stand, and then dive into all the themes and the details, which are very useful and what we believe will be a game changer for some things, for example, for cloud native operations, but more on that later on. So let's start with some platform updates. So as most of you probably know, is HiveMQ, the HiveMQ platform consists of multiple things and multiple products. So on the one side, HiveMQ has multiple MQTT brokers in the portfolio, which is basically, we have our open source version, the MQTT engine, our community edition, that is completely free to use, free of charge, and is open source on GitHub, which is very useful for proof of concepts, some smaller deployments, and so on. Then we have our professional and enterprise MQTT brokers and the MQTT platform, which consists of an enterprise grade, very scalable MQTT broker, which is used by companies worldwide to connect millions of devices and be at the mission critical heart of IoT deployments. And then also we have HiveMQ Cloud, a newly launched product in this year. We will also talk about later a bit, which basically allows you to use a completely MQTT broker completely managed by us here at HiveMQ. So we run it for you, and you can basically just enjoy the benefits of an MQTT platform in the cloud. So there are other things which you may or may not know. So we have also open source clients, for example, the HiveMQ MQTT client we developed together with BMW for mission critical and production use cases. This is a Java library, and this is used worldwide by developers for embedded devices, as well as for server applications consuming literally tens of thousands of messages per second, which is also very useful for big data scenarios. We also have multiple so-called enterprise extensions. For example, there are deep integrations with Apache Kafka, bridging to other MQTT infrastructure, and also we have something we call the Enterprise Security Extension, which is used by most of our customers in production to secure their MQTT deployments. And this is something we will also focus on today a bit. And then we also have some tools in the ecosystem. For example, with the Kubernetes Operator we will talk about today. We have testing tools for making it easy to integration test your MQTT applications, like the HiveMQ test container. And also we have command line utilities like the MQTT CLI, which is also part of our ecosystem. So this is where we currently stand. And today we want to introduce some new additions to this whole ecosystem. So one thing we want to also talk about today is HiveMQ Swarm. And for people who haven't heard about HiveMQ Swarm is a product we introduced earlier this year. And this is something that was a complete game changer for a lot of professional IoT deployments, because it solves a specific problem that was very tough to solve before, because there really didn't exist any tooling that could handle that. And this is load testing and benchmarks and scenario-based testing that allows you to retest your whole infrastructure and your whole MQTT infrastructure. And HiveMQ Swarm is a very powerful distributed platform that allows you to create millions of unique network connections for MQTT. So think about connected car scenarios, for example, where you have literally millions of devices moving around, having some behavior which is not always on the happy path, and HiveMQ Swarm allows you to simulate that. So you can test any scale up to 10 million devices. So starting from one device up to literally 10 millions of devices, millions of MQTT topics, hundreds of thousand messages per second, and so on. It allows you to develop reusable scenarios that simulates actual device behavior. So the times where you needed to code a specific behavior are now over. You can describe what a device should do, and then basically you can just run it. And you can also plug in custom data generators because sometimes real devices have some very, let's say, complex message formats, or you want to test some specific cases where data needs to be structured in a specific way. And this is something you can do also with Swarm. You can plug in your own data generators, and you can deploy it basically everywhere. So the thing about Swarm is it's really very simple. You have your Swarm controller, where you control Swarm as an application. Then there is a so-called commander application that uses an almost unlimited amount of agents, depending on the scale you want to test for, which can then test what we call a system under test, which usually consists of an MQTT broker infrastructure, as well as other applications like microservices, Apache Kafka, MongoDB, you name it. This tool is used by customers all around the globe for testing their test systems and staging systems with production load. So people really model scenarios based on their production load, and then do quality assurance of all the systems in the backend. And this is something we introduced, extremely powerful. We got some awesome feedback for that. And today we also talk about some of the things which are new in Swarm. So if you're new to this, stay tuned. Also, something we introduced this year is what we call the HiveMQ Kubernetes Operator. This is especially useful for people running cloud-native environments where Kubernetes basically is used for orchestrating containers, applications, and infrastructure. And the HiveMQ Kubernetes Operator comes with the HiveMQ platform. So for customers, this is free to use. This is part of the platform. So if you are planning to run on Kubernetes, or all are already running on Kubernetes, the Kubernetes Operator is really the way to go, because it's that simple to install. You can use predefined Helm charts. So it's literally 2 commands you enter, and then you have a running deployment. It can manage the whole HiveMQ extension lifecycle. So if you are bringing your own extensions, which is very often the case in production scenarios, the Kubernetes Operator can handle that. It also comes with Prometheus monitoring built in. So observability is basically enabled by default, unless you don't want to have an observable infrastructure, which is usually not the case. And it also supports zero downtime upgrades. So we have a concept called rolling upgrades, where the broker infrastructure is able to grow and shrink and roll out new infrastructure without any downtime at all. And it has integrated disaster recovery mechanisms, which is also very useful for cases which are not that happy, but of course can occur on cloud infrastructure. And a third thing which we recently introduced is what we call HiveMQ Cloud. It's a completely managed MQTT broker service in the cloud, which gives you a true multi-cloud experience. It's 100% MQTT version 3 and 5 compliant, and it's built for production. This is used, for example, for companies who have like large logistics use cases with hundreds of thousands of devices around the globe. Having mission critical logistics use cases 24/7, and customers like these rely on HiveMQ Cloud for their business operations. So this is run by us. This is especially useful if you do not plan to deploy on-premise. And this is something we launched in this year. But what we also launched is a completely free plan. So if you're planning to do proof of concepts, just need an MQTT broker in the cloud. We have a plan on shared infrastructure, which is where you basically get your isolated chunk of the shared infrastructure, where you can have up to 100 devices completely for free. And you can basically go there and just register for free, no credit card required, and go there and use it for free, up to 100 devices, 10 gigabytes per month. And if there's not enough, there's also a pay-per-use plan, which you can also use. So this is something you'll find on our website, hivemq.com/cloud, if this is of interest. So, but going back to the release today, the 4.7 release. The 4.7 release is something that brings a lot of interesting things. But before we go into that, people are wondering, okay, how often do we actually release? And let me clarify here. So in January 2021, we released our long-term support version. So for customers who don't plan to upgrade frequently, we recommend to go to the LTS release. The LTS release does not get any new features, but it will benefit from security maintenance updates also in the future. So this is something for people who want to run a more conservative deployment. So other than that, in April, we had the 4.6 release, and in September, the 4.7 release. And the next release is in January 2021. So we do 3 releases a year, which means new features will be rolled out 3 times a year. Of course, you don't need to upgrade, but usually some of the features bring so much benefit that it's usually a good idea to update. All of the previous releases also get, of course, updates. But if you are planning for a longer deployment, the LTS version is really the way to go. Okay, so let's now go into this release, 4.7. We focus on 3 things, which, and it's important to notice that our roadmap is very customer-driven and feedback-driven. So we got a lot of great feedback, and we have some very large and very ambitious MQTT deployments. So we have customers literally running tens of millions of devices in production. And there are some things which, we really got out of a lot of good conversations. Number one is we wanted to make it easier now to do cloud-native deployments. We have released a Kubernetes operator, but based on numerous feedback, we even made it better. And this is what we talk about today, but also other things that makes the life of administrators and operators much easier are also in this release. Also, we focus a lot on improved enterprise security. So there is, enterprise security is key for a lot of our customers, right? Because HiveMQ is usually also deployed in very complex IT environments where the security requirements are pretty tough and are state of the art. And HiveMQ is really built for that. And with this release, we bring some additional features customers were asking for, and what we believe can be standard for a lot of future deployments. And then also we focus a lot on HiveMQ Swarm, on the HiveMQ Swarm upgrade. So we brought a lot of new features here, which is for also allow you to test some other things, which we believe is really useful for testing sometimes abnormal behavior or things which are not on the happy path, but we also have added some goodies that a lot of users were asking for. Okay, but without further ado, I'd like to hand over to Georg, who will walk you through the changes in detail.
Hello, everyone, and thank you, Dominik, for getting us all on the same page on the HiveMQ ecosystem and how it all fits together. I would like now to take you on a journey into the more nitty-gritty details of this 4.7 release. So first of all, we released 4.7.0, so the .0 version of this new feature branch of HiveMQ, and released it yesterday. So everybody had a little hangover today in the morning from the release celebration, but all is good now, and we are up and here for you. This version will be supported until the 14th of September 2022. So this is the usual support cadence for a non-LTS version. A LTS version, like Dominik already mentioned, has a much longer supported time. Okay, what's in it? First, Dominik already introduced it. We made a lot of improvements to cloud-native operations. What is this about? So operations in very complex environments do not need to be complex. You can create a tooling, you can create the interfaces, you can create basically the methods to make that, to reduce the complexity to a very manageable level. Of course, you need good people there. Good people are always key. But if you give the best tools to good people, you get great results. For that, we added a feature into the whole HiveMQ ecosystem that we call machine-readable logs. What is this about? So in the past, as you can see on the left side here, logging was done in plain text. So we had a log statement, we had some internal structure of these log statements, of course, and some information could be gathered here. But basically, it was one sentence, one line in a log file. This is now changed. We have this optional enabled feature. So you get a much more structured output. The output is in JSON, which is the format for these kinds of logging. And then in addition to, so if you compare left and right, you can see that the time, of course, is there and the message is there. But you get more than that. You get more meta information about where this logging is coming from, what it concerns to, what events are handled in this log. So what you can do further down the pipeline then is sort these by metadata. And this is supported for all the major HiveMQ logs. So the HiveMQ log itself, the event log, the audit log, and the migration log. What you can now do with this is you can add HiveMQ to professional log shipping, to centralized log shipping. So the idea here is HiveMQ is a clustered software. So usually multiple instances are running in a cloud or even on local deployments. But you do not want, so you want to detect patterns or learn from the behavior or learn from the behavior of clients. And for this, you need to analyze the paper trail made by these events. And the usual paper trail for us is logs. And now you can centralize these structured logs into so-called log shippers. And what we are doing here, we are integrating, so the possibility is to integrate with all the major functionality here. So you can use the alt stack, you can use our partners Datadog, and you can use Grafana, Loki, you can use Splunk, and all of these work just right out of the box. Switch the logging to JSON, to structured logging, connect your log shipper, and you're good to go. Next. We had a major update of the Kubernetes operator. Dominik already introduced you to the concept of the Kubernetes operator. It is for easier deployment in cloud-native environments. And we had a big feature overhaul here. One of the important things, we are now supporting fully OpenShift. So this is a very popular Kubernetes implementation done by Red Hat. And the Kubernetes operator is now fully functional with the OpenShift. So HiveMQ has always been functional on OpenShift and always been working great with OpenShift. But now you can use the Kubernetes operator to manage your deployment here. Secondly, we added state-of-the-art security. When we added it, we improved our already existing security here. The patterns about how to do security in cloud-native environments are steadily evolving, and always new pattern emerge here on what is the best and the right thing to do to keep your deployment safe. And so one thing we added now is that all containers started by the Kubernetes operator are run in rootless mode. So we are dropping the permissions right at the start of the workload. Secondly, we added the possibility to directly interface with the Kubernetes secret objects for environment variables. So if you, for example, would like to have a Java key store because you obviously want to do TLS to your broker, encrypted communication, you can do that now via the Kubernetes internal APIs and over these secret objects. Last but not least, we increased the flexibility of Kubernetes operator deployments in general. So one thing a lot of customers asked us for was having the ability to start HiveMQ as a stateful set. This allows much better disk provisioning on a lot of the cloud-based Kubernetes providers here. So a lot of the I/O specifics can be now very fine-grained controlled. Additionally, we added a lot of other parameterization and scheduling options. We are talking here concrete about labels, annotations, sidecars, and so on. All these good stuff that really make it easy and a joy to work with a Kubernetes system. Next is we improved the enterprise security. So enterprise security in HiveMQ is done by the Enterprise Security Extension. That's where the name comes from. And Enterprise Security Extension has a big feature set already. So the main thing here is to integrate with third-party systems that allow for the authentication of the authorization data to be present for your MQTT deployment. Additionally, enterprise security allows to do the same thing for the HiveMQ Control Center. So users need to be authorized for accessing either of these, so either the MQTT part or the Control Center part. This is key for a secure deployment, and the easy is your piece of the puzzle to do that. And for this, we expanded something. We added Control Center OAuth authentication. So the possibility to do single sign-on. This is usually what this is used for. How does single sign-on, what is in it? Single sign-on allows you to integrate with any JWT-based OAuth platform out there. So there are on-prem solutions like ForgeRock or Okta. There are cloud solutions like Auth0, and so on and so on. And just pick what is your choice here, what you're already using, and it works now for the Control Center authentication. This is pure web-based technology. This means you don't need any other third-party system for authentication here. So no database is required, no LDAP. You can just stay in the browser and the whole flow is done in the browser. But of course, for authorization, you can do all of that. So you can integrate with other third-party systems. You can integrate with SQL databases. You can integrate with LDAP. You can integrate with this new thing that is file-based authorization systems, which I will introduce shortly to you. How does this look? Just demonstrate. So what we have here is a quick browser journey, how it would look. So we try to connect to Control Center, get automatically redirected to our authorization provider. We enter our credentials here. So you usually have an account at something at Okta or something like I said, ForgeRock. We sign in, and without any break in the flow, we get redirected back to Control Center and are fully able to go and logged in here. And what's happening behind the scenes is the full OAuth authorization token code flow. So this is the most secure and most advanced flow that is specified in the OAuth 2.0 specification. And this is really like the way to go for authentication for users in a web application, which is the HiveMQ Control Center. Next one is file authorization. Why would you need something like this? You have a centralized system usually, so we have big servers. File authorization seems a little bit off here if you look at it from a faraway perspective, but actually it is not. First, what does it contain? It contains file-based authorization information for the HiveMQ Control Center and for MQTT clients. So both branches that are secured by easy can now use authorization information from files. Again, like everything in easy, it can be done in a role-based mode and it can be done in a user-based mode. So for example, you have a role, so let's say administrators or users, and you give them certain permissions. And then you have user-based permissions. Perhaps you have one very important administrator or one account that is like a fallback account if everything fails, that you need to give expanded permissions. And this can be combined with everything in the authentication direction that we have right now. So with SQL base, LDAP, JWTs, or the just now introduced OR system. Why is this something good? Why is this something you want? What this allows now is have more static kind of authorization information. So a lot of deployments we see are very dynamic, of course. Huge expanding cloud-based structures with always new generations of devices are here, and you need new information. For this is not made, this is not the right use case for this. What is the right use case is if you have a very static authorization structure. So for example, you want to deploy HiveMQ to all of your factories. And basically your factories are set up all in the same way because they are doing pretty much the same thing. And what you now want to do is define centralized roles and centralized authorization structure, package that together with your HiveMQ deployment, ship it to your factory, unpackage it, for example, in a Docker environment or in a Kubernetes, and have already everything set up there, what you need to use your HiveMQ in a secure manner. You only need to add users, and then you're good to go. So this is now really something that you can do with these file-based authorization structures. How does it look in detail? What you have is now you can have one or multiple XML files. These encode the information. It allows, like I said, for user and role-based permission structures. And for the MQTT side, it allows a very fine granular permission structure. So the single permission, these are topic-based permissions, and you can see it here on the right. So for example, a topic could be a hash, so for a root wildcard, but it could be any complexity of topic filter. And then you can really drill down into the deep. So perhaps some user is only allowed to subscribe to a special topic or only allowed to publish. There you could do permissions based on what quality of service they are allowed to use, if they are allowed to publish retained messages, if they are allowed to enter into shared subscriptions, and so on and so on. So pretty much any functionality on an MQTT basis can be very granular and defined in authorization. Next is the same thing for the control center user. So if you already doing baked-in permissions into for the MQTT side, you really want to do it for the administration side as well. And this looks exactly the same from first picture, because it is basically. What you can do is you can do everything in one file if you like. You can have multiple files separated for example, MQTT and control center, and still have a very precise picture of your infrastructure here. The permissions, like all control center permissions we have, are semantic based. That means you really can tell by the permission what a user is allowed to do. So they are called like list client or show client detail or something like that. So you can really see at the first glance, what is this about? What can this group, what can this user do? Next, for the Enterprise Security Extension, is we have something that was requested a lot from us. It is the case conversion preprocessor. And to explain this, I need to go a little bit farther out and explain how the easy works in general a little bit. So the easy in general has a pipelining concept. And this pipeline concept means that for example, authenticating a client, an MQTT client, you go to separate steps. And the steps are basically first authentication and second authorization. But even these steps are further granular broken down into a pre-processing stage and a managing stage. The managing stage itself talks to the data source, either the SQL database, the LDAP server, the JWT provider, or the whatever. And the preprocessor does some work to make that use case specific. So for example, your clients connect with some special properties and you want to transform them before they go into the authentication step. You can do that in preprocessing. And one of these two transformations we added is the case conversion preprocessor. This was requested a lot because a lot of the authentication systems out there do not care about case sensitivity because they come from a time where this was not a thing. So for example, LDAP is a good example here. Usually everything LDAP is capitalized, but MQTT clients do. So the MQTT specification is fully case sensitive. And so a client name could be something that has, so basically a client name with a big capital letter somewhere is not the same as the same name with a small letter. And what you can now do is capture these cases and unify them for your authentication backend. Last but not least, the updates to Swarm. So Swarm was always about simulating large amounts of MQTT clients. At the beginning, our understanding of MQTT deployments was that you want to simulate only proper behaving clients. Our understanding involved here, we're talking a lot of customers, and edge cases do happen, and they do happen regularly. And only if your systems can handle these edge cases, you can be sure that your deployments are stable. And stability in deployments for mission critical infrastructure is key, of course. So what we added now is the possibility to simulate some not standard behavior. So imagine you have a car that is driving down a road, and it's all happy connected to their connected car platform, and everything is fine. It receives data, it can send data, but suddenly it drives into a tunnel and it loses connection. And what does this do to your MQTT deployment, of course? And how does it behave? This is something you want to find out. And this is now what we enable with the new Swarm features. What you can do is define very real life disconnecting behavior. So in a case like this, a car drives into a tunnel, the TCP connection gets dropped, and that car won't have the time to send the proper disconnect message. That will never arrive at the broker. But perhaps your logic depends on that, and you need to find out. So if you design a scenario to test your environment, you would need to design in some amount of clients that will disconnect without a message, or even just close a TCP socket without any other actions taken, or even worse, simulate a keep alive timeout. This is something we call internally half open sockets. So these do happen. That, for example, the backend still thinks it can talk to the client, but the client in reality does not. And so there's a feature in MQTT for that. It's called a client keep alive, and you need to run. And then if you run into that, the broker closes the connection from its side. And this is now something you can trigger via Swarm. Additionally, we added more functionality. So Swarm now does allow for message expiry to be set. This is another key feature because sometimes from a use case base or from a business case, messages are only worth their value for a certain time. So from the moment they reach the broker until they must be delivered, there is a timer running. And once this timer stops, the worth of the message is lost. So the broker should not deliver it anymore because you would deliver stale information to your downstream clients. And this is now something you can simulate with HiveMQ Swarm. We added last will and testament. Again, a feature that allows for interfacing with weird connection states, especially at the disconnect phase. We added a WebSocket transport and a secure WebSocket transport. A lot of deployments use this, and so it is only proper that we can simulate this. Yeah, that's basically it. This is an overview over the new functionality in HiveMQ 4.7. I invite you to try it out. You can download the 4.7 artifacts on our homepage from yesterday on. So just go there and check it out, play with Swarm, see what it does for you, and enjoy our new products. So I guess Dominik is now returning, and we will go to questions and answers.
Okay, so are there any questions? So you can use the Q&A window we have here. And then we are happy to discuss anything here. So, okay, so there's still some time, so you could use the Q&A. Yeah, here we have something. So, yeah, there was a question about any changes to max in-flight queue messages. So there haven't been any changes here. So, so this is a very technical question. So let me give some context here. So MQTT has basically a concept of queued messages, which means each device can have a queue of data when the device is offline. It will receive after it goes online again. And this is usually limited. So there is no changes in HiveMQ 4.7, but there have been changes which might be interesting depending on what the nature of the question is. Because, okay, here's some additional context. So the user asks if they can increase it to more than 1,000 messages per client. And yes, so there are multiple ways here. Number one, you can increase the limit globally. So there's a global configuration you can see in our documentation where you can increase that globally, for example, to 5,000. The thing here is you need to be a bit careful because very often it's not a good idea that you, let's say, increase it to 10,000 or even higher. Because what happens is if a device goes online again after some time and it will receive 10,000 messages, this is still a lot. HiveMQ is intelligent here with sending the data, but still is a lot of data to process. So usually we want to limit that. Something we see with a lot of customer deployments though is sometimes you have MQTT clients like backend clients, they really want to have a larger buffer, while you have other devices where you really make sure they only have a price, let's say 100 or 1,000 queue size, in the backend system 10,000 or even higher. You can do that. And this is also possible via the extension system. So because it's usually you use something like the client ID, the identifier, or some other clear identification, what kind of system that is. For example, also IP address or so. And with the queue, with the SDK, you can write your own extension to basically modify that. So if this is of interest to you, you can also reach out to us in case you don't find the option directly. And we can also discuss it also in the community forum, for example. So this is a very good question. So thank you for that. But for 4.7, no changes here.
And perhaps a good point to take up here is this is exactly the use case for Swarm, of course. How would you test if you increase the limit of something like this, of an internal data structure, if your deployment is still stable? So what you can now do is you use Swarm just to test it out. If your new configuration is a good thing, or if you need to be more fine-grained on that, because it can be possible, of course, that a global configuration is the right way to go. And now you can make sure. So the next question is about easy, and it's about whether it is possible to take the scopes of the JWT token, of the JW token, and access and map it to topic permissions. And this is perfectly possible now. This is one of the major advantages of the file-based authorization structures we introduced, because easy per default uses the scopes to grant user roles. And if you now use these roles to map them to permissions via a file, you don't need any other secondary system that gives you these information. So you can now directly take the scopes, have a file, XML file that maps these scopes to user permissions or to role permissions, and then go from there. So yes, this is now perfectly possible with Easy. And thank you for the question.
So I think we have another question for Easy.
Oh wait, let me just check, for example.
Yeah, so Daniel is asking, is it possible in ECE to authenticate clients via JWT with different scopes and limit the topics access via these scopes?
Yeah. So yeah, this is I think the question we already had. So we have two questions about easy. So with the JWT, I think we already answered, and then here we have one about bindings.
Yeah, and about bindings. So what this question is about is if whether easy allows for listener binding. So for example, different client types only defined to a different listener. And this is not what easy is for. So easy comes after the connection. But what you can do is you can do something we call TLS mutual authentication, and you can over that way bind specific clients to listeners. So only allowing, so for example, you could activate mutual TLS authentication for some listeners, and then set your certificate infrastructure up so that only special clients that have these certificates can connect to that special listener. Otherwise, easy comes afterwards. So the enterprise security integration comes after the client starts connecting. So on an MQTT basis, not on a purely TCP connection basis. I hope this answers your question.
So what is so possible perhaps to add here? You can easy allows for what the pipelines Georg introduced.
Yeah.
So you could very likely have different kind of pipelines. You have different kind of pipelines for specific listeners. So this is something that's possible. So for example, a popular use case is if you have, let's say, backend systems that use a different listener, that you have different authentication methods for that, because very often you want to have your devices in the field have different authentication mechanisms in your backend systems, and this is perfectly possible with easy. So you are pretty flexible here. Okay, we have another question. The question is, what percentage of customers do I need in your software? I think it's a tough question to answer when it comes to percentage, but one of the core product values we have here at HiveMQ is that we have flexibility as one of the most important things. Simplicity and flexibility are core for us. So while we strive to have, let's say, the use case, we believe 80% of people will have to make it as easy as possible to do. We also allow pretty powerful configurations, and we do believe in the configuration approaches that makes it easy for the user without any, let's say, coding. And with the last, even if you think, let's say you have some very unorthodox use cases, which is not covered by the Enterprise Security Extension or anything else, you can always use our SDK for modifying virtually any aspect, from data modifications, which sometimes people use to retrofit MQTT clients, which do not have proper, let's say, behavior. This sometimes happens. You can even modify MQTT let's say data sent to the broker. You can connect basically the broker to any backend infrastructure. You can use different kind of SDKs we have. You can roll your own authentication, authorization strategies, and so on. So this is really very flexible. What we do recommend, though, is to use an approach that is more standardized, but with HiveMQ is possible. Yeah. And if you are not quite sure if this fits your needs, a lot of the things, especially the extension SDK, is open source. You can find it on GitHub, so you can check it out yourself. So you should get a good grasp of what is possible. And this is only the open source version. The enterprise and professional versions are much more powerful, so you can get even more flexibility out of that. But also check out the documentation. If you're unsure, reach out to us, and we're happy to help you understand if it's possible to do what you're planning to do.
It is even possible to do more than that. So you could even take a standard solution like the easy and add additional custom logic to that. It's even as flexible to allow multiple extensions.
Yeah.
So I would say it's very flexible.
Yeah. So we also got a question here. If Swarm can be used as similar to anything else than connected car scenarios? Yes, absolutely. So we have customers who are running HiveMQ Swarm also for their manufacturing deployments. You can also basically simulate things like MQTT Sparkplug. This is a specification on top of MQTT for, let's say, manufacturing, oil and gas, the energy sector, and so on. So even for these kind of industry protocols, they can be used very easily. So yes, Swarm is really here. You don't need to simulate like your thousands or even millions of devices scenario, you can also run some very small scenarios and have it reusable all the time for your quality assurance. And what the beauty is, if you, let's say, simulate 100 or 1,000 or 10,000 MQTT clients, it's literally just adding 2 zeros or 1 zero to a config file. So I think this is the beauty here, and you can really do anything with Swarm you can do with MQTT. Okay, we also got a very interesting question here. Is there a best practice for setting up topic structures for asset information models? Are there sources to find examples for topic structures for different use cases? Oh, this is a good one, because this really depends on the industry, to be honest here. What we see a lot, though, is in the, especially in the last 2 years, the rise of MQTT, let's say, extensions for specific industries. For example, there's MQTT Spark Plug, and I will go into this in a second. MQTT Spark Plug. There is ITXPT, which for public transport. There is the VDA 5050 standard for autonomous guided vehicles, for example. And there are a lot of other standards you can find online, which are based on MQTT. And all of the standards have in common that they define industry-specific topic structures and data payload. And why is this important? Because MQTT is a very flexible technology that is agnostic of the kind of topic structure you're using, and is agnostic. It's also agnostic towards, let's say, the payloads and so on. And so this is also something we monitor very closely. So so you can expect in the next few months for us from some, let's say, major news on this front here. But what I can say is for MQTT best practices, I would actually look at things like MQTT Spark Plug for now. When it comes to let's say asset information models, it really depends a bit about what you're doing. So there are some other more, let's say, less used standards. I would recommend to just reach out to us here. I would be very interested in this conversation, what you're looking for, because I do think there are things we can help with. But I would need a bit more context to answer that question. But very good question. Thank you. Okay, so the next question is, can you say something about release plans for HiveMQ MQTT client version 2.x? Oh, it's a good one. So also for people not familiar with that, the HiveMQ MQTT client, as I said in the beginning of the webinar, is a Java library based on different, let's say, programming flavors, starting from, let's say, reactive programming to, let's say, a very simple blocking mode to even asynchronous mode. Which gives you the full flexibility for building MQTT applications. It's used for hundreds and thousands of projects where backend systems connect to MQTT brokers, but also devices. So, and this is something we built together with BMW in order to have something production ready, Java-based production ready MQTT library. So this is something we care a lot about because this code is running like all over the world in production. So what we learned over the years is that for most use cases, it's pretty much feature complete, and we're providing security and maintenance things here. So we do have some feature requests pending, which we would like to learn more about. So our version 2 is currently so basically a new version here is something like we do maintenance releases, but a new version with a lot of features. We don't have too much in the pipeline right now. But also, frankly, if there's any user feedback, then this is something that might very likely change. Because let's say for 90% of use cases, it really has the features it needs. Because I mean, an MQTT library is pretty narrow from a scope perspective, right? But we are eager to hear any feedback that might help you. And then, of course, we're going to improve that. So if you would follow up here, this I would be very interested in that. Okay, so there's a question about HiveMQ Cloud. So how is the pay-as-you-go plan? How is it comparing to the free plan? This is a good one. I think I haven't made it clear in the beginning. So we launched the HiveMQ Cloud free plan a while ago, which allows us to provide more than up to 100 devices for free, basically on a shared infrastructure, but you get your own topic namespace and so on. So it's really your own MQTT broker. You get provided for free, and you can literally get it in minutes. So go to hivemq.com/cloud, and then just register. No credit card required. So you can try it out. It also is a great quick start guide. So there are some specific things which we found out users really wanted to do. And while we have the larger plans for these enterprise-grade professional deployments, we also wanted to go and help also users which wanted a cheap and very affordable option for their MQTT journey. And this is where the pay-as-you-go plan comes into play. So you can connect up to 1,000 devices for 10 euro cents per month. And basically do your production grade infrastructure. You get also production grade SLAs. So this means you can rely on that. So even for important business operations with MQTT, you can rely on that because you get the SLAs. You can check out on our website. This is basically what it compares to in the next few weeks. So stay tuned for that. We are going to ship a lot of interesting things for HiveMQ Cloud, especially for the pay-as-you-go plan. So I cannot tell too much right now. So we will announce it pretty soon. So stay tuned. Also, if you have not registered on our newsletter, make sure to register there so you're the first to know as soon as we launch something. But we have some very exciting stuff in here. So stay tuned. But also the free version will get a lot of updates. So looking forward to announce that pretty soon. Okay, so we have 8 minutes left. So I think we have some slots for additional questions. So, okay, there is the Kubernetes operator. So basically, can you run the Kubernetes operator on all clouds? Yes, you can. You can run it on EKS, you can run it on AKS, you can run it also on the Google Cloud. So basically, it allows to run on any Kubernetes. So as Georg also mentioned today, we run on OpenShift also. So it's basically completely agnostic on the cloud and on the Kubernetes distribution. So I hope this helps. And other than that, I don't see any questions. So now is a good time for putting in the last question for today. Okay. We got also a very good question. So is there a 2 data center setup possible? So yes. So currently, what users are doing is they are basically setting up, especially if the data centers are very nearby, you can set up one cluster between data centers. It's not a recommended approach, basically, but this is something doable. So I can't go into too much detail, but especially for this kind of cases where you have these global MQTT infrastructures, there is something I wanted to also stay tuned. We are going to announce also something here very soon. It is possible right now, but we have some major news also coming that makes things even easier for these kind of scenarios. So thank you for that question. Then I think there's a question about, is there a way to broker files on request? So if I understand the question correctly, yes, you can. Number one, you can use files and send files over MQTT. You can send up to 256 megabytes of data per MQTT message, which is quite a lot. You even get, possibly you can send some video files or other stuff. We don't recommend it though. Usually for most MQTT scenarios, you are less than 1 megabyte of data. You can do more, but this is really more just from I wouldn't do that because most devices are not really built for handling this kind of large data. But yes, you can do that. So on request, it's a pub MQT, and MQT brokers use a pub sub model. So this is usually this is push. So if you send something to a broker, it will push data to all interested parties. Having that said, there is one feature in MQTT though that is fully supported with HiveMQ, of course, because it supports 100% of MQTT. You can use a feature called retained messages, which allows you to basically save on a specific topic data, like a file. And as soon as you have a device, like a mobile app or a car or a washing appliance, whatever you're using as an IoT device, and it connects to the broker and it subscribes to that topic where you just basically publish the file, and the broker will send it to you on demand as soon as you subscribe to the data. So technically, I would say yes, but I think I would need more context to answer the question properly. Okay, so I think, okay, so we have one question about AWS Fargate. So yeah, it's an interesting one. So it really depends on what you want to do. So most of the users actually run on infrastructures like Kubernetes and so on. So we don't have specific support for Fargate right now. So this is something, if this is of interest to you, please let us know. I don't see any reason why this wouldn't work right now, but this is not officially supported right now. So if this is of interest, I would ask you to reach out. Okay, so I think now we have 3 minutes left. So we could do one more question. Other than that, yes, so as you see here, if you want to learn more about MQTT and HiveMQ, you have here some very useful links. Also, if you want to rewatch the video, this will be published on YouTube, where you can also find other content where we are going into the nitty-gritties of MQTT, things like Sparkplug, and other, let's say, MQTT-related content for your MQTT journey. Let us know what you think. So yeah, and with that, I would like to hand over to Jayashri again.
Thank you, everyone, for participating today. So we will be sharing the recording in a follow-up email, and as well as we'll be uploading the recording to the YouTube channel. So thank you, everyone.
Thank you. See ya.
Bye.
Bye.